Welcome students. Earlier we have discussed about polynomial, in which we discussed the factor theorem. In factor theorem we have to substitute the value of x, and from that, getting the polynomial value as 0, we could have find the factors of the polynomial. Now in this case, in this session, we will discuss about some identities. Here we will discuss some identities already discussed in our previous classes, and some more identities to be discussed here and their application. Now this is one very familiar identity: x plus y whole square is equal to x square plus 2xy plus y square. Now let's discuss that what is identity. This is a statement, algebraic statement, in which x and y are variables. If we put the value of x and y here in left side, whatever result you get, if you put the value of x and y, same value, on right side, you will get this same value, and this will prevail for any pair of values of x and y. So these are called identities. Some more identities are: x minus y whole square is equal to x square minus 2xy plus y square, and x square minus y square is equal to product of x plus y and x minus y, and x plus a into x plus b is equal to x square plus x whole into a plus b plus a into b. Now these are the identities we have gone through before this class. Now we have to discuss some more identities. Let's start one by one. X plus y plus z whole square. To get this, let's start with its whole square. X plus y plus z whole square. Let's consider y plus z as one identity or one variable. Then we have, say, x plus m. Now this becomes, if y plus z is m, so this whole square becomes x plus m whole square. So what will be the result? What is its formula? As in the first identity, we have this is x square plus 2 into x into m. In place of m, now let me write y plus z plus, then m square. In place of m square, let me write y plus z whole square. This is equal to x square plus 2xy plus 2 into 2x into z, 2xz. Then here simply whole square of y plus z, so y square plus 2yz plus z square. Now let's rearrange it. On the square terms, x square, y square and z square first. X square plus y square plus z square. Then product terms, that is 2 into xy plus 2 into yz plus 2 into xz or zx, whatever you write. So our identity is x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Let's discuss another one. That is, here we have x plus y whole cube. X plus y whole cube can be written as x plus y whole square into x plus y. Now we have what is the identity gives x about x plus y whole square. That is x square plus 2xy plus y square. This is to be multiplied with x plus y. Now, by taking the distributive property, x square into x plus y plus 2xy into x plus y plus y square into x plus y. Here it gives x square into x is x cube, x square plus y gives x square y, plus 2xy into x gives 2x square y, 2xy into y gives plus 2x y square, plus y square into x gives y square x, and y square plus y gives plus y cube. This implies, this shows, let's arrange them in their power, that is x cube plus y cube, then x square and y term. X square y, 2x square y. That gives 3x square y and 2xy square, and here see y square x is same as xy square, so we can write plus 3xy square. Let be more specific, x cube plus y cube. From these two, this is actually the result, but let me take common 3xy. From this we get x, from this we get y. So this is a form easily remarkable or identifiable form, that is x cube plus y cube plus 3xy into x plus y. Similarly, as x plus y whole cube is like this, we can also find x minus y whole cube. X minus y whole cube is simple, very simple, as like this. This is x minus y to the power 3 can be written as x minus y whole square into x minus y, and x minus y whole square is x square minus 2xy plus y square. This is to be multiplied with x minus y. This is equal to x square into x minus y. X minus y is to be multiplied with each term. So x square into x minus y minus 2xy into x minus y plus y square into x minus y. Here, now here also again product of two monomial with a binomial, that is x square into x gives x cube, then x square minus y gives minus x square y, minus 2xy into x gives minus 2x square y, minus 2xy into minus y gives plus 2xy square, and y square into x gives plus y square x, y square into minus y gives minus y cube. Now let's rearrange it. We have x cube minus y cube, then minus x square y minus 2x square y gives minus 3x square y, then plus 2xy square, and here it is plus xy square. Sum of these two is 3xy square. Now as before, we can take common x cube minus y cube, and from these two we can take common minus 3xy. So from first we'll get x, and from second one we'll get minus y. So this is the form of x minus y whole cube, that is x cube minus y cube minus 3xy whole into x minus y. Now let's see another identity, that is x plus y plus z whole into x square plus y square plus z square minus xy minus yz minus zx. So x plus y plus z to be multiplied with x square plus y square plus z square minus xy minus yz minus zx. We can simply multiply x plus y plus z with x square, x plus y plus z with y square, x plus y plus z with z square, x plus y plus z with minus xy, and x plus y plus z with minus yz. So here it is written minus, and again with x plus y plus z into zx. If we multiply in first one, we have x cube, x square into x cube, plus x square into y, x square y, plus x square into z gives x square z. Y square into x gives xy square. Y into y square gives y cube, and z into y square gives plus y square z. In second line, we multiplied x with z square. We have z square x, then y into z square, we can write plus yz square. Z into z square gives z cube, minus x into xy gives minus x square y, minus y into xy gives minus xy square, minus z into xy gives minus xyz. And in case of third line, minus x into yz gives minus xyz, minus y into yz gives minus y square z, and minus z into yz gives minus yz square. Here again, minus x into zx gives minus zx square, minus y into zx gives minus xyz, minus z into zx gives minus z square x. Now if we look through it, then like this, x square y and minus x square y cancelled, x square z, and here x square z minus cancel, xy square minus x square xy square plus y square z, and minus y square z cancelled out. Z square x is cancelled out with minus z square x. Yz square x is cancelled with minus yz square. In this way, we have only x cube plus y cube plus z cube, and here 1 minus xyz, here 1 minus xyz, and here 1 minus xyz, minus 3 xyz. So from this we get that x cube plus y cube plus z cube minus 3xyz. Other way we can say that x cube plus y cube plus z cube minus 3xyz is x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Now let's see some applications. Using these identities, we have to find the product. How to find the product? How to use the identity? Without actual multiplication, we can perform the multiplication using some identity. 104 into 106. Here we need not have to multiply them directly. We can write it 100 plus 4 into 100 plus 4 into 100 plus 6. Just compare this with x plus 4 into x plus 6, or the identity is x plus a into x plus b, and this identity gives that x square plus a plus b into x plus ab. So we can write here that 100 square plus here a plus b means 4 plus 6 into x is 100 plus ab is 6 into 4. That means here it is 100 square plus 6 plus 4, 10 into 100 gives 1000 plus 24. The result is 11024. If we directly multiply, we can see that the result will be 11,024. Now let's see another example. Using identity, find 113 into 87. So what type of identity is to be used here? Just look at it. Here we have to find that 113 into 87 is 200 and half of it is 100. 113 exceeds 100 by 13 and 87 is lag by 13 from 100. So 113 into 87 can be written as 100 plus 13 and 100 minus 13. Now see this form. We can compare this with x plus y into x minus y. And what is it? X plus y into x minus y, we know this is x square minus y square. So we can simply use this, that 100 square minus 13 square. 100 square is 10,000 minus 13 square is 169. So this gives 1389. 9831. So without actual multiplication, just by applying the identity a square minus b square, we can find the answer. Then using identity, evaluate 23 to the power 3. What type of identity is to be used here? 23 is same as 23 cube is same as 20 plus 3 whole cube. Here this is x plus y whole cube form, which gives x cube plus y cube plus 3xy into x plus y. So here we have 20 cube plus 3 cube plus 3 into 20 into 3 into 20 plus 3. 20 cube gives 8,000. 3 cube gives 27. Now this is 3 into 3, 9. 9 into 2 is 18. 180 into 23. That is 8,000 plus 27 plus this gives 2318. 18 into 3 gives 54. 36 plus 5, 41. 414 0. Then this gives 7. 4 plus 2, 6. 1. Then 4 plus 8, 12. 1, 2, 1, 6, 7. This is the cube of 23. Now see, let's factorize x cube plus y cube using our identity. What is our identity? Here, cubic identity is x plus y whole cube. So, x cube plus y cube plus 3xy into x plus y. This gives x plus y whole cube. This is our identity as we discussed earlier. From this, we get x cube plus y cube is equal to x plus y whole cube minus, this part will shift to right side, gives 3xy into x plus y, and this is equal to, now here we can take x plus y common. From that we get x plus y whole into x plus y whole square minus 3xy. Now we can apply the identity of x plus y whole square here. From that we get x square plus 2xy plus y square, then minus 3xy. This shows x plus y, x square, c plus 2xy minus 3xy gives minus xy plus y square. So here x cube plus y cube is x plus y into x square minus xy plus y square. Here x plus y and x square minus xy plus y square are two factors of x cube plus y cube. Now another question using the identity of x cube plus y cube plus z cube minus 3xyz. What is that? We know that x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. And from this as x plus y plus z is 0, so this is 0 into something, that is x square plus y square plus z square minus xy minus yz minus zx. This implies x cube plus y cube plus z cube minus 3xyz is 0. So by taking this 3xyz to the right side, we get x cube plus y cube plus z cube is equal to 3xyz. Now, if we want to factorize x cube minus y cube, then simply take the identity x minus y whole cube. What is that? See, x cube minus y cube minus 3xy into x minus y gives x minus y whole cube. From this, we can write x cube minus y cube is equal to x minus y whole cube. This part will be shifted to the right side. That gives plus 3xy into x minus y. From these two, we have x minus y as common. Taking x minus y common, we have here x minus y whole square, and from here we have plus 3xy. So x minus y, and the identity of x minus y square is x square minus 2xy plus y square. Now write plus 3xy. So what is the result? X minus y into x square minus 2xy plus 3xy gives plus xy plus y square. So the factors of x cube minus y cube are x minus y and x square plus xy plus y square. Now see, x cube minus x cube plus y cube plus z cube minus 3xyz. This can be again written in another form like x cube plus y cube plus z cube minus 3xyz. This is simply x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. If we divide it by 2 and multiply 2 in the second factor, then we get 2x square plus 2y square plus 2z square minus 2xy minus 2yz minus 2zx. So 1 by 2 into x plus y plus z. Then here we can rearrange this as x square plus y square minus 2xy plus y square plus z square minus 2yz plus z square plus x square minus 2zx. Just rearrange this, we will get this one. Then what happens? Each is an identity. This is identity of x minus y whole square, and this is identity of y minus z whole square, and this is identity of z minus x whole square. So we can prove this. Now look at very interesting problem. This is x minus y whole cube plus y minus z whole cube plus z minus x whole cube. We have to factorize it. It seems to be very long, but how easily we can factorize it? Look at this. We know if x plus y plus z is equal to 0, then x cube plus y cube plus z cube is equal to 3xyz. Just we proved it earlier. Now you see, in place of x it is written x minus y. In place of y it is written y minus z, and in place of z it is written z minus x. So what is the sum? Here the sum is 0. This shows that x minus y whole cube plus y minus z whole cube plus z minus x whole cube is equal to 3 into, here 3xyz, so here 3 into x minus y into y minus z into z minus x. See, here this whole polynomial is expressed as product of three linear polynomials. So these are the factors of this one, x minus y whole cube plus y minus z whole cube plus z minus x whole cube. So today we learn about different identities, and what are the identities we studied today? Let's have a look. These are the first four are studied earlier in earlier classes, and today we learned about x plus y plus z whole square, x plus y whole cube, x minus y whole cube, and about x cube plus y cube plus z cube minus 3xyz. And we efficiently used it in some problems. Dear students, it's time now to leave. Thank you.